to this class. For today, we'll be doing on XUG 102, basic principle in survey part 2, right? So we will discuss an aspect under the principle in survey part 2 known as tacheometry, right? Tacheometry. So let's discuss tacheometry. So tacheometry. Tacheometry. So by definition, what is tacheometry? Tacheometry is a branch of surveying in which the horizontal and vertical distance can be determined using a tacheometer. I said a tacheometry is a branch of surveying in which the horizontal and vertical distance can be determined using a tacheometer. That's all. So that's like the definition for a tacheometry. When it comes to tacheometry, what are the various equipment established to the concept of tacheometry? Number one is tacheometer. A tacheometer is simply an instrument used for tacheometry activities. And also, we have what we call the stadia rod. They are like the two most important instruments when it comes to tacheometry. So I said the first one is a tacheometer, and the second one is what? Stadia rod. They are like the two very important tools when it comes to tacheometry. Alright, when at tacheometry, we have some various method or technique of taking the activities of tacheometry. The technique as follows. So we have the method of tacheometry. Number one, we have the stadia rod method. Stadia rod method. Number two, we have the optical method. Number three, we have this suspend bar method. Number four, we have the tangential method. These are like the four methods of carrying out tacheometry activities. So we have the stadia rod method, the optical method, the suspend bar method, and the tangential method. Alright, these are the four methods of carrying out tacheometry activities. Alright, let's discuss some important concepts in tacheometry. Let's start with number one. Some important concepts in tacheometry. Number one, distance. Alright, let's discuss distance. By definition, a distance is a space between 2 points. When it comes to tacheometry, distance, D, so we said distance is a space between 2 points, is represented by capital letter D. Hence, D is equal to Ks plus C. That's like the formula for distance when it comes to tacheometry, right? D is equal to Ks positive C, where K is called the multiplying constant, S is called the staff intercept, and C is called the additive constant. Alright, let's prove this. We said D is equal to Ks plus C. Proof. Now, once you prove this concept, it's quite simple, right? So, for most exam cases, when it comes to tacheometry, you will be likely asked. No, you will be asked. Because during my set, 2023, we actually proved this concept. So you have to prove why D is equal to Ks plus C. Now to prove this concept is quite simple. The first start is to memorize the diagram, which I'll be drawing out for you now. So the diagram goes this way. the diagram goes this way, something of this nature. I'll call this here X. I have this way, and call here B. I'll call here A, right? I'll have it in this format. Observe, if you want to prove D is equal to KS plus C, you have to memorize the diagram, right? So this is called, this rod here is called staff intercept. Staff intercept X, right? We call it staff intercept X. Here we call it O, the origin, right? So this is called the object lens, right? So this is called the instrument axis. Instrument axis, right? And also from the distance from here to here is C. From here to here is F. Finally, I have D. The entire length from here to here is going to be capital letter D. I have this. So, your first thing first is that to prove this concept is quite simple. Your first task is what? Draw out the diagram. When you are done, draw the diagram. What next? What are the next tasks? Your next task here is that start equating D over X is equal to F over I, or I say F over I is equal to D over X. So your first task is to what? Take F over I, right? Over I is equal to D over this X. So note that when after drawing the diagram, next task is to take F and I and D and X together. Hence, at this point, if I cross multiply mathematically, I'll be having that. I'll be having di is equal to what? Fx. From by what? Cross multiply, I'll have this. So, alright, at this point now, I'll divide through by what? I to make d the shorter formula. So divide by I. So I'll have di over I is equal to Fx over I. At this point, this cancel out this. I'm left with d is equal to Fx all over I. But when it comes to tacheometry, D, small letter d is equivalent to what? D minus F plus C. When it comes to, note that D can be gotten from the what? Subtraction of capital D from the sum of these two. So we said D, this D minus the positive of what? Of these two. So we can get D from it. Hence, if I put D here as equivalent to this, so anywhere I see this man, I'll put all this. So replacing this man with this, I will have D minus into F plus C in this manner is equal to Fx over I. Alright, at this point, take this man here to the other side. I'll have that D is equal to Fx all over I, then positive F plus C. I have this. So at this point, let F over I be equal to K, and also let F plus C be equal to C. So if I say F over I to be K, that is anywhere I see F over I, I'll put K. Anywhere I see F plus C, I'll put K. In that case, I'll have D is now equal to F over I is now K. left this x plus, we said f plus c now is now c plus c. Here is the proving to this man here. So here's the proving to how we got ks plus c, where k is called the multiplying constant, and s is called the staff intercept, which is gotten from subtracting the upper minus the lower limit. Please notice, staff intercept is gotten from the subtraction of what? The upper limit from the what? Lower limit. Alright, and c is called the additive constant. So this is like how to prove the concept of d is equal to ks plus c, right? So we said there are some important parts when it comes to tacheometry. We said number one is what? Distance, right? Number one is what? Distance. Let's discuss the second important technique when it comes to tacheometry. Alright, let's discuss the second important part when it comes to tacheometry, right? Which is called, the first one what we did was distance. The second one is called the horizontal and vertical distance. Alright, the horizontal and vertical distance. And vertical distance. Vertical distance. So let's discuss the horizontal and vertical distance. When it comes to horizontal and vertical distance, they are also among the most important concepts when it comes to tacheometry. So we established, if you recall, we said d was equal to what? Ks plus c. This formula was for dealing with, this formula is used when dealing with a horizontal plane, right? When your land per se is plane, right? So we apply d is equal to ks plus c. What of if your land is sloping? Let's say in this format or in this format. D is never ks plus c. Rather, d is equal to ks cos theta plus c is optional. The formula to solve for distance when it comes to incline at an angle is what? D is equal to cos theta plus c is optional, please. If you are given c to be 0, hence you don't need c. But if c is given, hence you add what? A positive c. I've showed you why d now is what? Ks cos theta plus c. So take note of these two concepts here, right? Now we said horizontal and what? Vertical distance. H is called the horizontal distance. It's given by is given to be ks cos squared theta, while b is given to be 1/2 ks, right? Ks sine 2 theta. Alright, this is like the formula to h and v. So let's prove this to proof. During our exam period, we were taught to prove this man here, that h is equal to ks cos theta and v is equal to 1/2 ks sine 2 theta. I was the only one that could solve this problem, right? So it's quite simple. So what are our first parts here? We said, this is first, to prove this concept, when we prove distance in our initial example now, when we prove d is equal to x plus c, we sketch what a diagram. So to prove this concept too, we need to what draw out what a diagram. So the diagram for this would be in this format, something of this nature. Have this in this manner, right? In this format, right? Something of this nature. This man will go down this way. Have this, right? Or O and E, E. X, right? So this is like the word. This is staff intersect, right? So now listen. This part here is called D, and D here is never Ks plus C. Rather, is what Ks cos theta plus C. Why? Because this is the initial line here. But the stuff here, the light here, is it's inclined at what? An angle theta. Hence, D can never be what? Ks plus C. Rather, D is what? Ks cos theta plus C in this case here. So we call this H, and if I take it this manner here, this is what? V. So this is like the imagination for this diagram. So if I look at this diagram with a layman eyes, I can see a rectangle triangle, right? So let's say I can see something of this nature. Observe something of this nature, where here is what? D, here is V, and here is H, right? So now, and here is what? Going to be what? Cos, theta, per se, theta. Now at this point, let's start with H. Let's look for H. So, proving for H. Now listen, I'm going to apply the concept of what? Socatua to prove this man. So, right? To prove this concept here. Now listen, I want to prove for horizontal distance first. So I'm giving horizontal and hypotenuse. So this is what adjacent here. I want to prove for horizontal distance H. To prove for it, I need just these two parts. Hypotenuse and what? Adjacent. This is opposite here. Hypotenuse, opposite, adjacent. So I am given adjacent and what? Hypotenuse. So adjacent and hypotenuse, I want to use what? Cos. So cos, we said from the idea of trig function, we said cos theta is equal to what? Adjacent over hypotenuse. In this case, what's my adjacent? H is my adjacent all over hypotenuse is what? D, which is D. So I'll be having that cos theta is equal to H all over D, right? But we said D is equal to Ks plus C. Sorry, Ks cos theta, right? We said that initially here. We said C here is optional, right? So if I put in value here, I'll have that cos theta, or perhaps if I multiply, I'll have D times this is what? D cos theta is equal to H. I can arrange this as saying H is equal to D cos theta. I'm still correct. But we said D should be what? Ks cos theta. So have H is equal to D should be what? Ks cos theta, right? All into cos theta. So if cos theta multiply cos theta, I'll have that H is equal to Ks cos squared theta as my answer. So these are the proof and D in this case. So this is what adjacent and what hypotenuse. Check for adjacent and hypotenuse. Sorry, this is opposite per se, opposite please. So I know opposite and what hypotenuse. So check for opposite and hypotenuse. This is opposite hypotenuse. So I'm using sine rule. So sine, we said but sine theta is equal to what? Opposite all over hypotenuse. So check. What is opposite? Opposite here is what? V. Alright. Opposite there is V all over hypotenuse. Check. Is what? D. Right? I have D. Hence, I'll have that sine theta is equal to V all over D. I'll have that sine theta is equal to V over D. At this point, right? At this point, I will multiply. I'll have that sine theta. I'll have D sine theta is equal to V. Right? Hence, I can take this as saying V is equal to what? D sine theta. I'm still correct. Now, at this point, but we said D is equal to Ks plus C. Right? So Ks plus theta. Right? We said plus C is optional. So at this point, if I put in D here, I'll have that V is equal to D is what? Ks cos theta all into what? Sine theta. But recall from the trig function that cos theta times sine theta is equal to 1 over 2 sine 2 theta, right? 1 over 2 theta, right? Hence, in this case, I'll have that V is equal to, listen, Ks is already there. Let's take 1 over 2 first. 1 over 2 first. Then we said this gives us what? Sine theta. So 1 over 2 Ks sine 2 theta. This is like the proof to this man here. 1 over 2 sine 2 theta. So here's like the first task when it comes to SUG 102 concept. So try to get this, try to understand this concept. It's quite important when it comes to tacheometry.
Alright guys, this is the Yaba College of Technology School of Environmental Studies, Department of Surveying and Geoformatics, second semester part-time examination 2022/2023, and the one civil engineering part PT of so course basic principle in surveying 2, right? So what we actually did now, we have actually solved a problem for question A1, right? So kindly copy down the question A1, I and II. We have actually solved the 2 from this video concept, right? So if you found this class helpful, do not forget to check do not forget to subscribe, like, and leave a comment down there. And if you have any question, you can just ask via the comment section. I will answer your question. Thanks for attending our tutorial.